everyone. I hope you enjoyed the talk by Gordon on Grails and the keynote by Kenneth. So, as Asim already introduced, briefed about Docker. So before starting the session, I would like to say that if you're not able to understand or if you have any questions, ask me whenever you want, because the best time to ask a question is the right time when you have it. So a little bit about me. My name is Puneet, and I'm an associate tech lead at To The New Digital. This is my email and GitHub and Twitter. Feel free to reach out to me during the talk, after the talk, and anytime you want to. So here's the agenda for today. We'll quickly understand the problem with the shipping of code. How many of you actually involved in shipping of code, deploying it to the servers or on-premises infrastructure or QA? Can I see raise of hands? Wow. It is expected from developer to do all sort of things. So we'll see what are the challenges over there. I hope you already know a few of them. We'll see what is the solution, what is Docker container, how Docker helps us prevent this problem, and a little bit understanding about architecture, and then we'll jump into a quick hello world demo, and then we'll see a little complicated example on how to Dockerize your application. Okay. Understanding the problem of shipping code. Let's see how things get complicated. So let's say we have a very basic application where you need a one web server, one container. Container, I mean Tomcat. You have a Java application, you have a database. That's it we need for a standalone, when we're creating a raw application from the scratch. Yes? So life is very easy. You are very excited to start a new project. You set up everything, install Java, latest version of Java, and you install MySQL, and everything is working fine. Hello world, and client is very happy. Now there are one more developer joins into the team. I said, hey, he has the same machine. Though the new version of Java came in, you notice that he installed the wrong version, you fixed it, and that's it. That is working fine. So far, so good. But what if there are so many developers now? You have a UI team, you have a DevOps team, you have some UX team, and everybody has different machine, right? Somebody is using Mac, somebody is using Linux, somebody is using Windows. Yeah, I really hate Windows, by the way. So everybody installed, you said, hey, these are the things you need to install. You maintain some Confluence or a wiki, and you install everything. And everybody set up, but everybody's saying that, hey, it is not working on my machine. Hey, this runs on my machine. And there are a lot of conflicts around it, believe me. And now you need a special team to actually set up everything on their machine. But since our application is very small or a standalone, it's quite easy. You can do that for a one time, right? Even if there is a new developer, you could easily say, install Java 8, this version of MySQL, Apache, and Tomcat, that's it. Yeah, there. That's not a problem, not a too much problem. So, but your application grows, you actually, now you are ready for one production version. So now you need to set up your environments, you need to set up your QA, right? You guys use QA. How many environments are there for a production application? Can you name a few of them? Staging, QA, production, demo, I guess. So, and it is not required that every environment is on the same infrastructure. Sometimes your QA is on your on-premises or locally installed in your office servers. Your production might be on cloud, might not be. So now you have to set up everything. You hired, reach out to your DevOps team, say, hey, I need this environment. Can you please set it up for me? He said, wow, yeah, I can do that, and he quickly, go and set up a QA, and you're fine, you're good. And now he say, can you set up a production environment for me on the AWS cloud? He said, yeah, I can create an AMI and I can do that. So everything is set up, but you need an expert to do that for you, right? And things are pretty easy as it's a very standalone and a very small app, but now things are getting a little bit complicated. You broke your application into some background workers. You don't want everything to be running in a standalone mode. Some emails you want to send in a background, so if that stops, your main application is working fine, right? So you break your application into 4 parts, and now you have to do that on each developer's machine, on each environment. And now you can imagine the problem or hell you're going to create, we are going to face going forward. So you have to go to on-premises infrastructure, make sure all the configurations are there, all the libraries are there. Again, you have to go to each developer's machine, Windows, Linux, different flavors of Linux, Mac. You have to set it up. Yeah. And now, a very big problem. Now you have a multi-service, microservice architecture where you are too much mature. You now say that, hey, I need a REST API endpoint. Hey, I need a Redis. Hey, I need a queuing mechanism. Hey, I need a static website. I need a blog website. I need a database. I need a search engine. Everything. So now you have to set it up on each environment, on each developer's machine. So now think of it, that the problem, how it works, and most of the time what we see that, hey, everything is working fine on QA, local machine, you go to QA, test everything, now you say, okay, let's deploy to staging, and suddenly nothing is working on staging. We are not confident that the things working on QA is actually working on staging as well. So I think of, this happens to me all the time, everything works on staging, but when I go to production, it breaks, and we say, fingers crossed, we are going live production today, so we'll have a party in the evening once it goes. So in a nutshell, what are the challenges? Works on my machine syndrome, hard disk crash. So on a fine day, you were very excited to do your job, and you came to office, and your hard disk crashed. And you're like, your hands are shaking, hey, what can I do with what should I say to my client? And I don't know how much time I need in order to set up a new machine, right? So that's a problem. Adding new developer to the team. So you need somebody to spoon feed him and somebody to set the environment for him, to give him context of how to deploy in QA, how to set up things on your machine. Going live, we already talked about it. Dependency health. Think of like, now you have a DevOps team which need a specific version of Python which is running on Linux, and you have some OS dependency on your application which requires a different version of Python. So now you'll have a battle, hey, we need to upgrade this. DevOps team say, you cannot upgrade this, please revert back your code. So this happens most of the time. So what is the solution? Any other solution apart from Docker?
Virtualization.
Perfect. Any other? Anybody of you worked on Amazon, AWS images, AMIs?
Yes.
Right, that is the solution. So what is the problem we face with AMI? So hey, I upgraded a version of Java in one AMI, so I have to restart a new AMI, create a new AMI, start every machine from that, and creating and starting a machine from AMI takes some time because it's installed, and yeah, and how easy it is to ship one AMI. Can you go from AWS to on-premises or some other cloud quickly? So let's say you have all the infrastructure on your office server. Now you need to move to the cloud. How much time you need in order to move to the cloud? So these are some of the challenges. Solution. So Docker. So let's talk about Docker. Docker, a container, is a lightweight. What Docker says that, hey, give me all the libraries and binaries which are required to run your application with your application code, so that I'm not dependent on operating system or underlying infrastructure to have those dependencies over there. So you just need a Docker engine installed over there, and Docker engine will take care of all of that for you. So, so now how it fits into the picture, like every small service, you're creating a Docker image or a running container from that, and that container has, for example, what you need for a background worker. So you don't need a web server because it is running in a background, so you ship all those libraries and binaries. You need Elasticsearch over here, you need database, so you are creating separate services, and somebody can quickly go ahead and say, hey, set up Docker engine on XYZ server, and then just run my images, that's it. You don't need to install anything else apart from Docker engine. And now you can see how easy it is to move from one infrastructure to another, or from your on AWS to, in order to move to AWS, how easy it is. You could simply install Docker engine and just simply say, hey, just go there, that's it. And The reliability in terms of confidence. So since it is not dependent on underlying operating systems, everything is shipped with the code. So which means if things work on your staging, it will definitely run on production because it is exact replica of production. There's no other magic going on production which is required to run your application, right? Sorry. So what is a Docker container? Container allows application developer to package up their application dependency. So the diagram in the right actually depicts how it works. That you have a server, you have a host operating system. On top of that, you install Docker engine, and then you have this containers which have application code and your binaries and libraries. You understand the term binaries, like bin files and libraries, jar files. So, okay, I understand Docker containers now. They are like VM, right?
Looks like it.
Looks like it? No? So what it is? Let's see the difference between the Docker container, application running on a Docker and a virtual machine. So I'm not saying disadvantages or advantages, it's a difference. So let's see the virtual machine first. So as you can see that you have infrastructure, host operating system, some hypervisor, and you have this virtual machine image, which also includes guest operating system, application, and binaries. So the problem with this image is it's very huge. You have a whole operating system with this. It is very hard to maintain. It is less, not portable. It's very big. You cannot send it quickly to other person or some other environment. And and whenever you start an image, you are actually starting a new operating system, right? And with the Docker, so you have infrastructure, operating system, Docker engine. So operating system is removed from the image. So you just need the code and libraries. Your operating system is already running. So you are sharing the kernel and running on top of it. So the size is very small because it does not contain a guest operating system. It is very fast to scale up or down because it is very small. So it does not require to run a whole operating system every time you create a container from an image. So this is it. So some of the benefits of Docker: scalability. The containers are extremely lightweight. As I explained, that does not have guest operating system, so you could quickly scale up and down based on your needs. And portability, just pull the latest image and start the container, that's it. So images are very small, so very handy to port from one machine to another. Deployment, because container can run almost in every environment, you just need Docker engine, so deployment is very smooth. So there are some public-private repository like Bitbucket, Git. There is Docker Hub for Docker, where you push your images. Since it is sharing the guest operating system and the underlying resources and kernel, so it is efficiently utilizing all the resources. Why developers care about Docker? Hey, it's the job of DevOps, not mine. Why should I care about it? Yeah. So you have an advantage since you're not dependent on DevOps or somebody else to set up infrastructure for you. So whatever you need to build, just build and ship it with the dependencies and libraries. So any stack of language or anything you want to build with. So you're not dependent on anyone else to set it up for you, and you have less conflicts. Can run anywhere. It'll give you confidence that things are working on one environment, it will always run on others. Helps improving application design. Yeah. So you're now more focused on the application code, not the deployment and other configurations. DevOps care, so easy migration to different infrastructure, replication. So you could still say to your client, you know what, I need 7 days to move to cloud. And you could say, okay, it's done in 1 day. So 6-day party. Just kidding. Replication of different environment is very easy. Fix an issue once, it is fixed everywhere. Less conflicts between developers and DevOps. Why business care? Since it gives you much more confidence, and moving from one environment or deploying on different infrastructure is quite easy. So it actually boosts productivity, reduce cost by saving time, and reduces risk as well. So far we got to know the problem and the solution, how Docker fit into the picture. Do you have any questions so far? Okay, I'll move forward. Understanding architecture real quick. So Docker core components is Docker daemon, which is responsible for which run on the host machine. Host machine is a server, right? Your AWS machine or any server you're running. So where Docker engine is installed. So Docker daemon is actually responsible for spinning up of new containers from the images. And there is another term, Docker client, which is responsible for interacting with the user, which sends command to Docker daemon to start or stop containers or create image, whatever. Workflow components, Docker image. Docker image is a read-only template to start up a container. So think of it like so there is a very interesting thing about Docker images. So since it contains application code and libraries, so every time I make a change, I need to push the whole. I do not need to push the whole image again back to the repository. It just pushes the delta like Git. So that makes it much more powerful that every time you are starting up something or you have some changes, it is only fetching the changes, not the whole image over from the repository. Registries are like GitHub. There are private and public repositories. One of them Docker Hub. So where you can, have private repository with your own images, or there are a lot of public images like Ubuntu, Mongo already out there, so you could use them. Containers are runtime, where you run your application, which is created from an image. So this is the whole architecture diagram. So you have Docker host. Sometimes your Docker host and client can be daemon and a client can be on same machine, or it can be on. It could be interacting with an API. So you have images. This is right on the right. There is a registry. So you said, hey Docker, build something. Pull. It will go to the registry and pull the latest image to the local and start the containers from it. When you issue run command. And if the image is already there, you don't go to the repository. Say, hey, I already have the image, and with the latest changes, it spin up the new container. That's it. Installation. It's pretty easy. If you're using Linux, you could just do apt-get install Docker engine, or if you're using Mac, there's a Docker for Mac, Docker for Windows, or you could install Docker Toolbox. So you could follow the instructions on this page. Yeah. So with Docker Toolbox, there are 3 utilities which comes, which is Docker engine, which is daemon and client, Docker machine, Docker compose. There's another utility we'll talk in later slides. Hello world demo. Let's quickly see our hello world demo. So how many of you know this code? Spring. It's a Spring code. Only one. That's it. Wow. Okay. So it's a very it's a web application written in Spring. So in order to run this, you need Spring and Java in order to run this jar. So you could simply start a web application from this code. That's it. So yeah. Can you see the font? I can see this.
Yes.
Yes? Okay, perfect. Okay, hello world. Hello Docker. So I already created a jar just to save the time. So in order to run Docker, so you say Docker is prefix, so you use Docker. So PS is a command to show all the running containers. So right now there is no container. So Docker images is a command to show all the images. So you understood the image, so which I already fetched from the repository. So I have in Linux, Java, Ubuntu, or Hello World. So you say Docker run Hello World and command to run this java-jar hello.jar. Oops. So as you can see, Docker jar file is already in this folder. So I should be able to spin up a new container from an image and pass this jar file and execute it. So let's run this. So, oops, there is some error. It says error response from them and invalid error failing OCR and migration. It's a very strange error. Any guesses? What's the error?
Bin is what? Java bin?
Yeah. Let me pass.
Puneet, can you please bring the text to the top? Thank
That's
you.
it. Yeah. No worries. I need to mount this hello.jar into app. So I'm mounting current directory into the app folder inside the container. So let's run this again. Oops, yeah. It should run now, hopefully. Just let me know when you see the text that it is running. Yes? All right, let's go to the browser and see. Okay. I'm typing localhost 8080. It's not running. What's the problem? It says it is running.
Port forwarding.
Yeah, very good. So network is also isolated. So you need to bind that port from a container to the port of a host machine. So very good. So let's do this now. So I'm binding port 8080 from container to the host machine port. Damn, I always put space. Thanks. As a developer, you can do this. Is it up? I guess yes. Come on. Yay! It is running. That's our first demo of the talk. All right. So, any questions on that? Isolation, network, and volume binding. All right. So let's move forward. So you could. This is one way of running a container from an existing image, Java 8, which is actually pulled from the Docker Hub. And another way is to create a Docker file which has all the required command. For example, it's a blueprint to create a new image from an existing. So you might want a customized image for your own application. So I'm saying, hey, from Java 8, who is the maintainer, add this jar into this image, expose port 80, and use this command when you are running this image. Okay? So you could actually, let's see, to save the time, I've created the video. Let's see. I'm sorry for this. Cool. So yeah, this demo I already showed you. So this is the Docker file inside this directory. Right? This is the same as I showed you in the slides. So let's move forward. So I said Docker build. Docker build is a command to create a new image from a Docker file. So I said this is Bhagwat, my co-presenter from the last time. So you can create the new Docker file from this build command. So T is the name, the tag for the image, new image, which is used to used for you to push to the new repository. So please make sure whenever you're creating a new image, this is Bhagwat Kumar is actually your username on the Docker Hub. So you need to make sure you append this on every image name if you want to push it to the Docker Hub. So, and hello Docker is the name, and dot is to get the Docker file from the current context. So this will pull up Java 8 from remote, add a file, and the image is successfully reports. So as you can see, Docker images are now, you will have a new image named Bhagwat Kumar Hello Docker in your images. So you'll say Docker history to search for history of any specific image, how it is made. So since you could create a new image on top of it, so it will show you, hey, Java 8 and what is added on top of Java 8 in terms of, in similar way the Git commits work. Yeah. So this is history of this specific image. So added a file, apt-get installed something for Java 8 image, and after that, from here it says maintainer, add file, expose port, and this is the entry point for this specific image. So in order to push this image to Docker Hub, so you first need to log into the Docker Hub. So the command is docker login, and then you need to enter your username and password. And then to push the image, you'll say that, hey, Docker push Bhagwat Kumar or whatever your username is, hello Docker, it will be pushed to your Docker Hub repository. Pushing. So if you noticed here, it is not pushing the whole image at once. It is pushing the commits or the changes, individual snapshots of the image. So for example, we added one more thing, so it will not push all those changes once more, it will only push the last change here. Yeah, sorry, never mind. So it's just a pushing. Let's move forward. So we saw a Hello World demo, but what we really want is how can we deploy a microservice application or a multi-stack application to Docker. So this is a very a smaller version of a multi-stack application where you have a web application which requires Node, Angular, JS, Bootstrap. You have a proxy on top of it. You have a Node, Angular, another application, or two applications running the same. Yeah, it's two containers, and one database, one Spring Boot application, some background workers, a client which is using REST API, and web browser which is using the front-end part. How can we create this using Docker? So Docker Compose is your friend. So MongoDB, here if you notice, MongoDB is another one image, which is referring from Docker Hub. And there is another backend service, which is referring an image from Docker Hub saying Puneet Behl backend. So these are individual images for the previous containers. So for example, I need one image for this two web applications. I need another image for a proxy server. I need another image for MongoDB. I need another image for background workers. So yeah, so we have MongoDB, we have backend, we have front end. So to keep it simple, I have these three for now. So what all other things are here? Links. It is so in order to communicate between one container to another, you have to create a link between the containers. So, for example, how do you know which port? What is the URL? You have to write in your application to connect to MongoDB, right? So you have to create links for that. So you could refer MongoDB as a URL inside your application, and which port is exposed to the outside world. So it says that port 8080 is exposed for this application. some environment variables, some local configuration you call it in terms of your web application, right? So that you can do it. Again, front end is exposed on a different port, and it links with the back end. Front end does not require a database, so it is actually using APIs which communicate with the back end, and which is backend server URL is this, and command to run this front end is node. This is entry point or CMD command which we saw earlier in the Docker file. So let's see a quick demo of this as well. So just to see, this is so I'm not doing this demo on my machine because it will kill the internet. It will take huge time to load all the images and run it because it's just very fresh. So I already have a recorded video, and it's a very new machine which does not have anything apart from Docker. So that's what I'm showing in the initial steps of this video. So Docker, yeah, we have Docker installed. So we'll see Docker version to check which version of Docker is installed. We'll say Docker images, what images? No images so far. We say Docker PS to see all the running containers. No containers are running on this machine. We say Java, Java is not installed, as you can see, right? We say Mongo, we need Mongo. Mongo is also not installed. Yeah, just to cross check, MongoDB is another. We see Node.js, so this is nothing is installed on this machine, and we really don't need them to be installed on the server or host operating system. So I have one Docker compose.yml, that's it I need. That's what I need to run my application. So I say, just to show you content of Docker Compose, it's same as I showed you in the slides. All right. So in order to run containers from a Docker Compose file, you need to say Docker Compose up, and it will download all the required images, create links, and spin up new containers for you. So everything will be set up for you. Docker Compose, let's see what it does. Pulling MongoDB. Let me fast forward it, because it's pretty fast. So it is pulling changes on the images, pulling backward, backend, pulling front end image, and it started running the application now, containers from the images. So this is a Docker hub, and you can see all the images, and let's see. This is DNS mapping we already did for that server, and yeah, so this is port 8080 of the same machine. So this is a small to-do app which we created with that architecture I showed you in the Docker Compose file. So it's working. Could add a doc to do. So remember we run front end on the port 3000, right? So it is 3000. So that's it. That's what we need to do in order to spin up a new server. So, moving forward. So there is one problem right now. We did not talk. We only showed you Docker Compose, and it is running on a single machine where I installed Docker Engine. But this is not how the production works, right? Productions have clusters and multiple machines underneath, which are so that if one machine goes bad, another machine is up and running, and your application is not down. So to move to production, there are multiple orchestration tools available. So Docker Swarm, AWS also provides some services which you could use to directly create Docker images, push Docker images on that AWS service, and it will spin up containers, and you need not to worry about underlying servers. So the way this works is you have one layer. Beneath you have all your machines, smaller, higher, for example, some micro instance, some medium instances, and you say, hey, I need these many containers with these services, and you are just worried about running them, and this swarm layer or this orchestration tool will take care of where it needs to run those containers on which machine. So that's how it works. So Docker Swarm, Centurion, Amazon EC2 container service is also there. So that is it for today. Any questions, Dad? Yeah, go ahead.
So you have multiple applications, and all the applications need Java environment, right? So right now on our production there is one Java, and all the applications are using that Java, right? So if we are deploying with Docker, there are multiple images of Java, right? So isn't it heavy as compared to the initial one?
Yeah, that's a very good question. So let me show you something. So as you can see, it will download the images inside this image inside a host machine. So it will not replicate the same image since it has layers of images. So it will reuse the part commit where it is Java 8, right? So there will be only one Java 8 over here. So you don't need multiple Java 8 images. So every image is a layer, so it will reuse whatever is already there. Yeah, do you have any other question?
Yeah. So you told there are multiple environments like staging, like production, and we have some configuration depends on the environment.
Yes.
Right. So there are different Docker images for different environment.
You could always externalize configuration as system properties.
Okay. So Docker can, the Docker file can use the system, the external files, configuration.
Yeah, indeed. That's what I showed here. This is reading from system property, environment variable.
Okay.
Right?
So we have to specify here now.
Yeah, you have to specify from where it is reading. So you'll create separate image for a backend and a front end, right? On per environment, the image will be same, but the values of these configurations will be different, right? That's what you're saying.
Yes. Okay. Thank you.
You had one question.
Yes. I have a question since I'm in my company, we are already set up with the production and everything. Now I want to include this Docker in it. So what are the things I have to keep in mind working on this? And also, we deal with content management. So it's not like the whole part of files like you need to have Java over there. Everything is in place. We just need to have my code over there. And the configurations also keeps on changing from QA, from production.
Yes.
So it's like now what will be the first step to move to the Docker?
Yeah, the first step would be to create an image with all the required libraries and dependencies. For example, if you need Java, just create an image, your own image from Java, and any other service you need to run on that Java machine. And then I would say add some command in a Docker file saying pull my source code from this place and just run the image. That's it. But that's a very interesting thing. Sometimes the application is very small, so it does not make sense to have Docker over there. For example, for a very standard application, I might not need to go with it. But as my application scales, Docker provides flexibility and maintainability. So that's when you really see the power of Docker. But yeah, to answer your question, you could create a Docker image with all the libraries and dependencies which your application required to run. So you don't need to break your application initially.
So how confident I would be? So since I'm using for the first time, so where I should say that yes, I wanted to use Docker now. So it's like only complications. Complications are everywhere in different fields. Like I'm using a Alfresco as a content management, and I have a development environment where I'm using only the Tomcat. But in the production, I have the Alfresco provided .exe, which I have installed over there. So it's like in developer, I can push my files one by one, and I start the server and it's running fine. But what about the production? production,
So-
the Docker is not in my hand. It's like I have to start from the command prompt or something like that.
So you just need to install Docker engine on the production, and you can push the same image. So you don't need anything else from any other party to be there to run your application. So the whole concept of Docker is your environment, your local, your QA, your staging will be exactly same as production. But
So-
yes, I understand your problem where you are saying there are some restrictions from the third party. But maybe I think we can deal with this question later after the talk. Yeah. Any other questions? Yeah, that's it. Thank you, folks.